Welcome students. In this video session, I am going to discuss about simple LR parser. Simple LR parser is a type of bottom-up parsing where we will be starting with the input string and we will be ending up with the starting symbol of the grammar. Now in the simple LR parser, we have three steps. The first step is construction of canonical LR0 collection, then construction of LR parsing table, and then finally implementation of LR parsing. Now first let us discuss about the first step, that is canonical LR0 collection. Now let us discuss with an example. Now consider the grammar with 6 productions. Now to construct the canonical LR0 collection, the first step is we have to convert this grammar to an augmented grammar. That is the first step. So augmented grammar in the sense, we have to introduce a new symbol and that symbol should lead to the starting symbol of the grammar. Now in our case, E is a starting symbol. Now we are just introducing a new production, E tends to E. So E tends is a new symbol and this symbol is leading to the starting symbol of the grammar. So once if we introduce this grammar, then the grammar will be an augmented grammar. In the rest of the productions, we are not doing any changes. The only thing is we are just introducing this production. Suppose if in your grammar, if S is a starting symbol, then you can include a production like S dash tends to S to make your grammar as an augmented grammar. Okay, so now this is an augmented grammar. Now we can proceed with the construction of canonical LR0 color. So the first step in the construction of canonical LR0 collection is we should have an item called I0. Now in this I0, we have to include the first production, that is E dash tends to E. Okay, so the first production, we are just including it. E dash tends to E. Now in I0, what you have to do is, before E, we have to place a dot symbol. The meaning of this dot symbol is that, it means that before the dot symbol, it has been already processed, and after the dot symbol, it is yet to process. That is a meaning of placing a dot symbol. So to the left side of the dot symbol, whatever you have, it has been already processed, and to the right side of the dot symbol is yet to be processed. It will be processed by the parser. Okay. Now, since we are proceeding, that's why it is E dash tends to dot E. Okay, fine. Now, in the canonical LR0 collection, we have to perform two operations. One is closure operation and other one is go to operation. Whenever we are constructing some item sets, now I0 can be called as an item set. Whenever we are constructing an item set, and in that item set, if dot is being followed by a non-terminal, then we have to go with closure operation. Suppose if dot is being followed by terminal, then we have to go with the go to operation. Okay, fine. Now let us proceed with the canonical LR0 collection. Now this is the only rule first we have included here. E dash tends to dot E. Now as I said, here dot is followed by a non-terminal. Since dot is followed by a non-terminal, we have to go with closure operation. So what is closure operation? So in closure operation, what you have to do is dot followed by some non-terminal, right? So those non-terminals production from augmented grammar should be listed here. So which are the production rules we have in the augmented grammar? So here after dot we have E. So the production for the E non-terminal should be included here. So what are the production? E tends to E plus T, then E tends to T. Now with both the productions we have to include dot in the left hand side. So dot E plus T dot T. Now again you have to check whether there is any possibility of applying closure operation. So let us check here. It is dot followed by E. Of course, it is a non-terminal. Dot followed by a non-terminal. But this E already we processed it, right? Here in our first production rule, it is dot E. Because of this non-terminal only, we have included these two production rules. So this E already we have included it. So we do not worry about that. So let us check with the next one. Here it is dot followed by T. It's a non-terminal, right? So what do you have to do? So we have to list the production rules for the non-terminal T. So what are the production rule we have? So T tends to T star F and T tends to F. So list out them. And as we did in our earlier case, here also you have to put dot symbol in the left hand side of the rule. Okay, so it is dot T star F dot F. Now again check for closure operation, whether any possibility for applying closure operation. So it is dot followed by T. So T already we processed. Okay, so we not worry about here. Then here we have dot followed by F. So it is a non-terminal. So we have to list the production rule for the non-terminal F. So what we have? F tends to within bracket E, then F tends to ID. So list those productions and also put dot in the left hand side. Now just let us check for the possibility of closure operation. So here dot followed by bracket, right? Open bracket. So it is a terminal. So we cannot apply the closure operation, right? So let us check with the next rule. It is dot followed by an ID. It is also a terminal. So here also there is no possibility. Now what we did is we constructed the item set called I0. Now next what you have to do is we have to proceed with go to operation. Now in go to operation, what we have to do is we have to try to take this dot symbol one position to the right side. Okay, we will be trying to take this dot symbol one position to the right side. Okay, now first let us consider the first rule. E dash tends to dot E, right? So let us try to apply the go to operation, right? Now first what we are doing is that after considering this I naught, we are going with go to operation. I naught of E. I naught comma E. So it means that we are trying to take this dot symbol to the next position. Okay, so we will be getting a new item set. Let us name it as I1. Now in I1 you will be having E dash tends to E dot. So we are just shifting this dot symbol one position to the right side. So dot we will be getting it here, right? And similarly you also have one more production, that is dot followed by E, right? So we have to include both the productions also. I'll repeat the point once again. See, when you say that go to of I naught comma E, it means that you have to refer those productions in which you have dot followed by E. So here we have in two productions we have dot followed by E. So first we have processed it and second one also we have to process it. So it is nothing but E dash tends to E dot plus T. So that is what we just shifted the dot symbol to the next position. Okay. So once after shifting the dot symbol to the next position, try to apply the closure operation. When we will be applying the closure operation, if dot is followed by a non-terminal, we will be applying the closure operation. So here the dot is followed by nothing, right? So there is no possibility of applying the closure operation. Here dot is followed by plus symbol. It is a terminal. Okay. So here also there is no possibility. So next what we can do, similarly, let us try to take, or let us try to move the dot symbol to the next position in this rule or in this production rule. That is, let us try to take the plus symbol after t. Sorry, let us try to take the dot symbol after t. Okay, fine. So go to of I0 comma t. So when we go to this operation, or when we apply this operation, what happens? We have to look for those production rules in which we have dot followed by t. So we have two production rules in which we have dot followed by t. Now in this rule, two rules, what we have to do? We have to shift the dot symbol to the next position. So E tends to T dot. And similarly, in the next rule, T tends to T dot star F. Okay, so this item set we can call it as I2, and also check whether you can apply closure operation. Here also there is no possibility of applying the closure operation because the dot symbol is not followed by a non-terminal. In first case it is empty, dot followed by an empty, and here the second production dot followed by star. So no possibility of applying closure operation. So let us proceed with the next one. The next go to operation, that is I0 go to of I0 comma F. So what we have to do now? We have to look for the production in which you have dot followed by F. Okay, dot followed by F. Now, so when we implement this go to operation, what happens is that now in this production rule, the dot symbol will be moved to the next position. So it will be I3, and then this item set will be I3, and I3 will be getting T tends to F plus, just shifting the dot symbol to the next position. Now here again you have to, you don't have any other production with dot followed by F, only one production we have, and that in that production also we have shifted the dot symbol. So you'll be getting only one thing, and you have to also check whether there is any possibility of applying closure operation. Here there is no possibility because dot is followed by an empty space, right? So let us proceed further. That is, go to I0 comma open bracket. So when you say go to I0 comma open bracket, so what does it mean? It means that you are trying to move the dot symbol to the next position. That is, you are trying to move the dot symbol after the open bracket in this production rule. Okay, so F tends to open bracket dot E closed bracket. Just in this production rule, you are just moving the dot symbol to the next position. Okay, fine. So you have only one production, right? Only one production rule with dot followed by open bracket, right? So we have moved that. Now we have to check whether closure operation is possible. Now in this case, closure operation is possible because the dot is followed by a non-terminal. So you have to go with closure operation. So what we'll be doing with closure operation? So for the symbol for the non-terminal, whatever we have after the dot symbol, so that non-terminal production rule from augmented grammar should be included. So what are the grammars, what are the rules we have? E tends to E plus T and E tends to T. So include those two production rules. And in the left hand side, we have to include dot symbol. Okay, so dot E plus T and E tends to dot T. Right? Now again we have to check for closure operation. So here it is dot E. E already we have included it. So no need to worry about it. The next one is dot T, right? So here also dot followed by a non-terminal. So we have to do, we have to go with closure operation. So in closure operation, we will be including the non-terminals production from augmented grammar to this item set. Okay, so what we having? T tends to T star F and T tends to F. And in both the productions, we have to include dot in the left hand side. Right? So again, check for the possibility of applying the closure operation. So it is dot followed by T. Already T we processed it. And then dot followed by F. So what we have to do? It is a non-terminal. That is dot followed by a non-terminal. So you have to apply closure operation. So include the production rule of the non-terminal F. So we have F tends to E, F tends to open bracket closed bracket E, and F tends to ID. And we have to also include dot symbol in the left hand side. Okay, so this is how we have to implement the goto operation. Now still we can do one more operation. We can implement one more goto operation. So that is goto of I0 comma ID. Goto of I0 comma ID. So when we implement this function, what happens is the dot symbol will be moved from this position to after ID. So F tends to ID dot, and this item set we can call it as I5. So far what we did is, for item 0 we have shifted the dot dot symbol to the one position towards the right side. Okay, so for various non-terminals and terminals, we just shifted one position right side. And when we shifted to one position right side, we are resulted with different item sets. We have got I1 item set, I2, I3, I4 and I5. Now again what you have to do is, whatever we did for I0, the same thing should be done for other item sets also. So let us proceed with item set I1. So in I1, now what you have to do is, we have to try to shift the dot symbol to one position right side. Now let us take the first one. It is E dash tends to E dot. So here, if you consider this production rule, already the dot symbol has reached the end. It is not possible for it to shift furthermore to the left side, because it already reached the end of the rule. So this rule we can ignore it. Let us consider the second rule, that is E tends to E dot plus T. Now here what we can do, we can try to shift the dot symbol after the plus. So let us implement the function goto of I1 comma plus. I1 comma plus. What is the meaning of this I1 comma plus? Why we are implementing this I1 comma plus? Because here in I1 we have one rule, E tends to E dot plus T, and we are going to shift the plus symbol. We are going to shift the dot symbol after the plus symbol. That's why it is I1 comma plus. So once if we shift the plus, shift the dot symbol after plus, what happens? E tends to E plus dot T. Okay, so we're just shifting the dot symbol after plus symbol. Okay, we shift. Now once after getting this production rule, we have to check whether there is any possibility of applying the closure operation. Is there any possibility? Yes, we have a possibility. That is, the dot symbol is followed by a non-terminal. So if the dot symbol is followed by a non-terminal, then what we have to do? We have to include the production of the non-terminal from the augmented grammar. Okay, so here it is T. So what you have to do? We have to include the production of T here. So T tends to T star F and T tends to F. So include it. And whenever you are including it, you have to put the dot symbol in the left side. So dot T star F dot F. Is it okay? Fine. Now again check for the possibility of closure operation. Here it is dot followed by T. Of course it is a non-terminal, dot followed by non-terminal, but this T already we have processed it. Already we have computed closure of it. The next one is dot F. So what you have to do? Dot followed by a non-terminal. So we have to apply the closure operation. So we have to include all the production of F from the augmented grammar. So F tends to open bracket E closed bracket and F tends to ID. And in the production, we have to include the dot symbol in the left hand side. So this is how we have to calculate. For I1, we have shifted the dot symbol to the next position. Is it okay? Fine. Now let us proceed with I2. So in I2, when you consider I2 item set I2, in the first rule, already the dot symbol has reached the end, so there is no other possibility to take it further because already it reached the end. So let us proceed with the next rule. T tends to T dot star F. Now here what we can do, we can implement the function goto of I2 comma star. Goto of I2 comma star. So when we implement this function, what happens? We will be getting a rule like T tends to T star dot F, just shifting the dot symbol after the star. Okay, fine. Now once after implementing this, we have to check for the possibility of closure operation. Yes, here we have a possibility, that is after dot we have a non-terminal, so we have to include the production rule from the augmented grammar. So here after dot we have F, so we have to list the production rule of F. So the production rule of F is F tends to dot open bracket E closed bracket, then F tends to dot ID. Okay, and let us call this item set as I7. So far we have processed I0, I1 and I2. Let us proceed with I3. So in I3 we have only one production rule, and in that also the dot symbol is reached the end. Okay, it is not possible for it to take it further, so let us not worry about I3. So next one is I4. Okay, so in I4 we have different rules, so let us try to take the dot symbol to the next position. First let us consider the non-terminal E. So let us define a function called I4 goto of I4 comma E. So goto of I4 comma E, when we define this function, what happens? F tends to open bracket E dot closed bracket, just shifting the dot symbol after E. And similarly, we have one more production. See, whenever we are applying goto function, we have to refer those productions in which we have dot symbol followed by the terminal or non-terminal which we are defining it. Here we are defining for E, so it means that we have to refer those productions in that item set which is followed by this E. So dot followed by E, we have to look for those productions. So here we have dot followed by E. Here also you have dot followed by E. So we have to refer these two productions. Okay. So in those productions, we are just shifting the dot after E. So we will be getting F tends to open bracket E dot closed bracket, and the next one is E tends to E dot plus T. Okay. So just check for closure operation. So here it is no possibility of applying closure operation because dot T is followed by a terminal. Here also dot is followed by terminal plus. So here it is not, there is no possibility of applying the closure operation. So let us proceed further. So next we can define the function I4 comma T. So what is the result? I4 comma T. So I4 comma T in the sense, so we will be getting the production rule like E tends to T dot and T tends to T dot star F. Okay, so these two item sets, these two production rules will be getting it, but this production rule already we have it in a set called I2. Okay, so we are getting the same set. This set is not a new set. The same set you already got it when we are defining the function goto of I0 comma T. Okay, so the same set we are getting it. So we need not give a new name for it because this set is very similar to that of I2 set. So let us have the same name I2. So let us proceed further. So let us define goto of I4 comma F. Okay, I4 comma F. So next one is go to of I4 comma open bracket. So when we define I4 comma open bracket, what happens? F tends to open bracket dot E. Okay, open bracket dot E will be getting it. Now since this is an dot symbol followed by a non-terminal, you will be applying the closure operation. Once if you apply the closure operation, you will be getting all these productions. And this item set is not a new item set, is very similar to of I4. Okay, so when we apply go to of I4 comma open bracket, it is resulting with item set I4. Okay, so let us proceed further. Still we want to define I4 comma ID. So I4 comma ID, again if you implement it, what happens? You will be resulting with I5. Why we are getting I5? Because in this production you will be just shifting the dot symbol after ID. So when you shift after ID, it will be F tends to ID dot. Is it okay? Right? So it is not a new set, so it will be the same set I5. So we completely processed I4. Now let us proceed with I5. Let us try to define the goto function for I5. In I5 already the dot symbol has reached the end, so it is not possible for you to shift to the right side because it is already reached the end. So let us go with I6. In I6 we can move the dot symbol after T. So we have to define the function goto of I6 comma T. Goto of I6 comma T. So once we define it, what happens? The dot symbol will be moved from this position to this position, right? So E tends to E plus T dot. And the next rule is T tends to T dot star F. Okay, so it is a new set. Let us give the name as I9. Okay, now also check whether is there any possibility of applying closure operation. Here there is no possibility because the dot symbol is not followed by a non-terminal. In first rule, the dot symbol is not followed by anything, and in second rule, it is dot followed by a terminal. So there is no possibility of applying the closure operation. So let us proceed further. So let us define the function I6 goto of I6 comma F. So when we define that function, what happens? Once again, I'm highlighting that point. Whenever we are defining the function, we have to refer those production in which the dot symbol is followed by the particular terminal or the non-terminal. When you are defining I6 comma F, you have to look for those production in I6 in which dot followed by F you have the right hand side of the production rule. So here we have dot followed by F. So only this rule. Okay, only for this rule we can apply the function. Okay, so T tends to just shift the dot symbol after F. So it is T tends to F star. It is very similar to of I3. Okay, so let us have the same name. This I3, and then next one is I6 comma open bracket. So I6 comma open bracket. When you just shift it, you will be getting F tends to open bracket dot E closed bracket, and since it is a non-terminal, dot followed by non-terminal, you will be applying the closure operation. So you will be getting the same I4. Since I don't have space, I just included only 4 productions. Okay, so you will be getting all the productions. Okay, you will be getting the same item set I4. Okay, fine. So still we want to define one more, that is goto of I6 comma ID. So goto of I6 comma, still you have a goto of I6 comma ID. So when you define goto of I6 comma ID, you will be getting F tends to ID dot. Okay, so that will be equivalent to your I5. Okay, I haven't defined here. So for goto of I6 comma ID, it will be resulting with I5. You'll be getting the same production. Okay. Okay, fine. So next one is we are just moving with the next item set, that is I7. So go to of I7 comma F. What happens? You'll be getting like T tends to T star F dot. Since it is a new set, let us have it as I10. Let us have the name as I10. And there is no possibility of applying the closure operation because dot followed by nothing. Okay, so we cannot apply closure operation. The next one is I7 comma go to of I7 comma open bracket. So when you implement this, you will be getting like F tends to open bracket dot E closed bracket, and again you will be applying the closure operation for this E. So once if you apply it, you will be getting the same item set as I4. Okay, so you'll be getting I. The next one is I7 comma ID. So when you define the function, what happens? We'll be just shifting the dot symbol after ID. In this rule, we will be shifting a dot symbol after ID. So F tends to ID dot. Even here it is I5. I just named it as I7. It is I5. Students, it is I5. Okay, fine. Then we have defined for all the productions in item set I7. Next we have to go with item set I8. So here we can define the function I go to of I8 comma closed bracket. So okay, go to of I8 comma closed bracket. So when you define it, it is F tends to open bracket E closed bracket dot. So let us name it as I11. Then here again you can define the function, that is go to of I8 comma plus. So I8 of plus, when you define it, you will be getting the same item set like I6. You will be getting the same I6, you will be getting it. So like this we have to compute the go to for all the item sets. Okay, so whatever we have computed is what canonical LR0 collection. We will be using this item sets for constructing the parsing table, for constructing the simple LR parsing table. We will be discussing elaborately about parsing table construction in our next video. Thank you, students.